And before going to the topic, so today my topic is on the technical intricacies, that is challenges which we face while designing or planning the industrial sheds in oil and gas refinery projects. And before starting the topic, I would just take a moment to emphasize the importance of steel. Like, steel is one of the vital aspects of stable growth and economic development, and also it is the preferred material of choice due to its abundant availability, strength, versatility, ductility and recyclability. And also it accelerates the construction speed, and also it enhances construction quality, and it provides the most economic solution in terms of the life cycle cost. So in oil and gas refinery projects, sheds are one of most essential structures, and they are well known for their structural arrangement, creating a large space without columns, which is very much required in our projects. And also these sheds generally be used for warehouse, workshops and housing compressors and pumps. And here are some of the photographs. You can see the compressor house on the right side. Yeah, here is my project. This is the one of the shed in a grassroots refinery project, and it is part of the FCC unit, which is also known as fluidized catalytic cracking unit. And here this shed is housing 2 power recovery turbines, and power recovery turbines is key component of the FCC unit. And coming to the salient features of the shed, the span of the shed is of 20 meter plus 20 meter, that is overall it is 40 meter span, and height of the shed is around 36 meter, which is more than 10-storied building height. And bay to bay spacing is around 12 meter, and the shed is having 2 EOT cranes of capacity 30 ton each. And so here is the arrangement of power recovery turbine along with its inlet and outlet lines and the EOT crane. So this is the power recovery turbine, which is structure mounted, it is supported an RCC structure, and these are the inlet lines, which is of 86 inch, that is around 2.2 meter, and this is the outlet line, which is 128 inch size, and it is of equivalent to 3.25 meter. And here the EOT crane is provided at 27 meter height. And here inside the shed there are operating platforms for maintenance of the PRT, which are at 4 meter height. Next, just I want to brief the process involved in the FCC unit. So this is the regenerator part. Here from regenerator, flue gases of very high temperature and pressure comes out, and these are then sent to the third stage separator, where the catalyst fines are reduced. Here this was sent to the third stage separator to avoid the damage of the expander of the power recovery turbine. So after passing through the third stage separator, it is then sent to the expander, where it drives the generator to generate the power. So power is recovered from the hot flue gases coming from the regenerator, and this power can be used in the refinery, and also it helps in overall CO2 emission capture credit of the refinery. So from there, after passing through the power recovery turbine, the flue gas is then passing through the flue gas duct, where the flue gas is further treated to meet the environmental regulations and control the emissions. And from there it is then passed through the stack and then it is released to the atmosphere. So coming to the design significance of the shed, as we know that span, height and the EOT cranes, these all affect the design of the shed. And along with, we also know that wind is one of the predominant load case which governs the design of any shed. So here in this project, the wind speed is of 47 meter per second, and the average wind pressure acting on the shed is of 200 kg per square meter, and it is generating a shear force of 400 tons and overall moment of 6600 ton meter. So this is the typical structural arrangement of the shed, where we have, due to the high forces and height of the shed, here we have used the twin column sections, two WPB wide flange sections with lacing with the angle members, and on the left side you can see the typical arrangement of the crane girder supporting member. Here you can see up to the crane supporting level we have provided the twin column sections, and above that it is a single portal frame for supporting the roof. And this is the longitudinal elevation of the shed, wherein the longitudinal beams are the twin sections, again twin sections of made of WPB sections, and here up to the crane supporting level all the longitudinal beams are provided with the moment connections with columns to provide stability, and above that we have provided the bracing system. And in this view you can see the roof plan arrangement of the shed with all plan bracings, and the total tonnage consumed in the shed is around 900 metric ton. So this is the empty section wise quantity which we have used. So here is the comparison of the 3D model and the actual executed at site. So while designing the shed, some design challenges what we have faced was, first of all, the base plate. Here due to the height of the structure and due to high wind speed, here the base plate thickness was coming very significantly very high. So we could not make it a single one. So we provided a stool type base plate and separate for both the columns. And next is the supporting arrangement of the 30 ton capacity EOT cranes on twin column at mid-span of the shed. Planning of the same is also one of the challenges we have faced. And next is already I have shown in the earlier slide, like heavy pipes which are of 128 inch and having a very high temperature are passing through crossing the shed, and these require very supports at a height of 20 meter, which is a challenge for us. Like if you see, these are the supports are just adjacent to the frame of the shed. So placing these trestles, clearing the shed and all, it's a very tough job. And also this pipe, due to the heavy forces, we cannot support it on the shed frame. So we have to isolate them. So we have provided the two trestles and with the pile foundations. Also inside the shed, due to so many components inside, like equipment, its associated inlet outlet pipes, EOT crane. So erection sequence is one of the major things which we have faced. So see, proper planning and effective planning of the erection is very important to reach the milestone. So here is the construction stage-wise photos. In the first photo, you can see the sheds of the columns were first erected, and after that the equipment was erected, and after complete equipment erection, the main inlet outlet lines of the equipment were erected, and after this the top roof and the EOT crane is erected. So this is the overall view of the FCC unit of one of our project. Okay, thank you very much.